So we want to figure out what the electron geometry and the molecular geometry is for this particular molecule, which is xenon tetrafluoride. So first, draw the Lewis dot diagram. And so we're going to have xenon with its 8 valence electrons. We're going to have F with its 7 valence electrons, but there are 4 of those. So 4 times 7 is 28, plus the 8 gives us a total of 36 valence electrons. Xenon goes in the middle. 1, 2, 3, 4. That's going to subtract off 8 electrons from there, leaving behind 28. And then we put a 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Minus 24 from there, it leaves behind 4 electrons, so there's going to be 2 pairs. 1 pair there, 1 pair there. So what we see is that there are 6 electron pairs, 4 bonding, 2 non-bonding. And then we'll look at our VSEPR diagram to tell us what that is. Now I want to show you where to find this VSEPR handout on the website. I'm going to give this to you on the exam, so I'm going to slide this around a little bit. So I'm just on BB Learn now. So this is in BB Learn. So there it is. And then I'm just going to now scroll down here, and there it is right there, VSEPR handout, right? And that's these guys. And we are looking for 6 electron pairs. So that's going to be octahedral. 6 electron pairs is the electron geometry, and 4 are bonding and 2 are non-bonding. And that gives us a molecular geometry of square planar. Whoops. Pull this guy back up. Pull that up. Okay. So we've got octahedral is our electron geometry. And then we're going to have square planar is our molecular geometry. And there's only one choice there, and that's the hybridization has to be sp3d2. Sorry, it's sp3d2, because there has to be 1, 2, 3, 4, 5, 6 orbitals to get the 6 electron pairs. So that's our hybridization. It is octahedral and square planar. Question number 10 here asks, what is the hybridization at the carbon in C2F2? So C2F2, C2H2, C2X2. This is acetylene, basically is what this is. So you need to draw the Lewis dot diagrams. If you do that, you will see that this looks like this. And what do those carbons look like? There is sp, that is an sp hybridized orbital. That is an sp, that's a linear molecule, right? So if you draw the dot diagram, find the geometry, find the electron pairs, and then look at table 7.1, it will tell you that those are sp, and they have to be in order to form the 2 double bonds that it does form, because remember, there are 3 p orbitals, and they are orthogonal to one another. And if we've taken away one of those, so let's take away this one to make that sp, that leaves these 2 guys that are orthogonal. And that means there's going to be a p orbital up here, a p orbital up here, and then one coming out of the plane, and that's what forms that double bond. So that has to be sp hybridization, leaving behind 2 unhybridized p orbitals. Remember, because what we have is s, and we have the 3 p's, so s and p's, and if we do an sp hybrid, those are the ones we're using up, leaving behind unhybridized p orbitals. And that's question 10.